I see what's happening here. You're face to face with JavaScript and it's strange. You don't even know how to feel. It's adorable. It's nice to see that programmers never change. Open your eyes, let's begin. Yes, it's really me, it's Monad. Breathe it in.
Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. Our feature flags are powered by LaunchDarkly. Check them out at launchdarkly.com. And we're hosted on Linode Cloud servers. Get $100 in hosting credit at linode.com/changelog. What's up, JS Party people? Have you ever wondered if you could be offering a faster, less buggy experience for your customers? Well, with Raygun error and performance monitoring, you have all the information you need at your fingertips to quickly find and fix errors and performance issues across your tech stack down to the line of code. Raygun makes it easy to monitor the impact of your performance improvements, quickly identify issues across web and mobile apps, and see how your code performs in the hands of your customers. This saves you time, this saves you money, and this saves your sanity. Head to raygun.com to join thousands of customer-centric software teams who use Raygun every single day. Again, raygun.com to give them a try with a free 14-day trial.
This is JS Party, your weekly celebration of JavaScript and the web. We record live on Thursdays at 1 p.m. US Eastern, and you can be part of the show. Come hang with us in our community Slack. It's totally free. Head to changelog.com/community and sign up today. Okay, let's get into it. Hey, it's party time, y'all. Ain't no party like a JS party because a JS party don't stop. Hey y'all, it's Jared, your internet friend. And I'm joined by a couple of my friends. It's K-Ball. What's up, K-Ball?
Hello. How's it going?
It's going just fine. A lot better now that you're here. And Nick is also here. What's up, Nick?
Ahoy, hoy. It's going well.
Glad to hear it. And ahoy, hoy back to you, sir. So we have a fun show planned for you all today. We're going to play an old game. Pull it out. Try it on for size, explain it like I'm 5. Now, if you recall, the last time we did some recurring segments, we had a good friend from GoTime, Matt Ryer, on the show, and we ambushed him. Asked him to come up with some new jingles on the spot. Well, unfortunately, Matt is not here, and we do not have an Explain It Like I'm 5 jingle. But I thought if I exploited Matt Ryer to get a jingle, who else could I exploit to get a jingle? And I realized I have kids. And I can use them to our great advantage. So I have a brand new jingle ready for you right here.
Can you explain it like I'm 5?
So explain it like I'm 5. It's self-explanatory. If you're older than 5, we take complex technical subjects and we try to break it down or metaphorize them or do something to explain it to somebody who's younger than ourselves, maybe around 5 years old. So today we're going to tackle 3 topics of varying degrees of difficulty. I think they're probably all pretty hard to explain. WebAssembly, React hooks, and Bitcoin. So we randomly selected people to explain these. No, we decided who was going to explain these before the show. And it turns out K-Ball is going to do WebAssembly for us. So K-Ball, can you explain WebAssembly like we're 5?
Explain WebAssembly like we're 5. All right. So I was trying to think about different ways we could explain this, and I'm going to try Legos. Okay. So when you get a Lego set, you've got these like super small basic pieces, and then you have these instructions that kind of build up those basic pieces into larger chunks, and then you put the chunks together and you get like a full, awesome, like, I don't know, Hogwarts Castle, which was the biggest Lego set we did recently. So if we think about that the other way, if you start from the vision of what you want to do, that's the most kind of descriptive. I want to build a Hogwarts Castle. We could think about that as a very descriptive programming language, JavaScript or C++ or Rust or something like that. Then we break it down into chunks that are still potentially pretty descriptive. So in our Hogwarts castle, that might be, okay, we're going to do the tower, or we're going to do the the secret chamber, or something like that. Those are our high-level language instructions. So, functions in JavaScript or other things. But computers don't understand those high-level things. They need to get down all the way to the level of the Legos, and that is an assembly language. So this is true across all of our different software development, right? Anything you do, web or not, you end up having to break it down to these very finite level instructions that are not very descriptive. And we have tools to do that. We have compilers that do that. We have runtime interpreters, things like that. So that's like one set of concepts, is you have these multiple layers of increasing complexity. We might call those layers of abstraction, but 5-year-olds probably don't understand that. But we call it Lego blocks, chunks of Legos that like at the scale of a room, or like the whole set. And in order to get something to run, we need to map things down from those high-level concepts into the Lego blocks and understand what they need to do. Traditionally, on the web, the only way we've been able to do that is we get it down to the level of the intermediate blocks, JavaScript, and the browser does the translation into smaller Lego blocks. And what WebAssembly is doing is saying, okay, let's actually create a way to control things at the level of those smallest Lego blocks. And what that lets us do is use other types of languages other than JavaScript to program for the web. So we can, instead of just always having to build to JavaScript and trust that the browser is going to translate that to Lego blocks in a good way, we could build in another programming language. We could build in Rust. We could build in C++. We could build in something else and use a compiler designed for this purpose to translate that down to these lowest level Lego blocks that are called WebAssembly. Does that feel like a 5-year-old explanation?
Maybe like you came up with it when you were 5. No, Nick, what do you think? Pretty good?
Dad, I just want to play with my blocks.
Well, and you can. You can write raw WebAssembly. That's okay. Most people won't be doing that. So that's actually a really important thing to think about if you're thinking, I'm going to learn WebAssembly. You can do that and you can learn how to manipulate assembly, but just like very few people who are coding for non-web environments are actually directly coding in assembly, very few people who are coding for WebAssembly are going to be directly writing in WebAssembly. Most folks will be writing in some sort of higher level language and using a compiler to translate it down into WebAssembly.
So in this Lego blocks metaphor, where does these other languages, like there's Rust, not bindings, but cross-compile to WebAssembly, Go can compile to WebAssembly, I believe. Are these like Lego instructions that are written in other people's languages, or how's it fit
Sure.
in?
Yeah, I think that's reasonable.
Dang it, I shouldn't have given you an out like that. That was such a good out.
Yeah, I think that's a good way to think about it. One interesting thing is probably the simplest things to translate into WebAssembly and the languages that first created WebAssembly approaches are those without a runtime. So I don't know if we want to get deep into runtimes or lack of runtimes or things like that, but JavaScript has a runtime, which means there's a set of libraries and function calls you can call. WebAssembly essentially has that same access to that same runtime, and it doesn't have extensively other pieces like another language runtime like you might have, for example, in Golang. So if you're going to ship a Go program as WebAssembly, you need to not only ship the program, but you have to ship the whole runtime as WebAssembly so that you can run it there. Whereas runtime-less environments like Rust or C++, those were the first languages to be shippable to WebAssembly because you could just compile them down. And I see Matt is commenting in the chat, so he might be telling me where I'm wrong about Go.
Pay no attention to him.
Does he know Go?
I don't know.
That joke's a no-go. Tell me how Lego Mindstorms fit into the mix.
Tell me what a Lego Mindstorm is.
I'm just trying to make it harder on you. All right. Well played. Well played. Now, sometimes with the problem with Legos is they can be expensive. Is WebAssembly expensive?
No, WebAssembly ships for free with your browser today. You
All
can
right.
do it. And all of the tool chain for pretty much every language that I'm aware of that compiles to WebAssembly is free. I think you can... The first versions were built on entirely open source, and I don't know if there are proprietary compiler tools that also compile to WebAssembly at this point, but you should be able to get started for free.
Awesome. Thanks, Dad. All right. Nick, you're a dad.
Yeah.
You're a React daddy. Can you explain React hooks to K-Ball? This was K-Ball's request, so I totally understand them, but K-Ball needs help. Please explain them to K-Ball like he's 5.
All right. Well, I'm going to take a shot at this. And just so you know the mindset of which I'm coming to this from, I do have an almost 5-year-old, and I was trying to think of how I would explain this to her and kind of what her favorite things are right now. And her favorite bedtime routine right now is kind of coming up with stories about our day that are just completely silly and maybe tying in like TV or movie references that she knows just to make them even more silly. And so that's what I did with this. I'm going to try and explain React hooks to K-Ball, who I'm thinking of as my 5-year-old.
I kind of act like I'm 5.
Once upon a time, there was a community of JavaScript developers that lived on an island. I'm tying in Moana right now, in case you need to know.
Thank you for the reference.
Yeah.
Oh, good. I know that one.
Spoilers for Moana, by the way. This was a very special island full of proud people who braved the waters of the JavaScript language and even forged their own destiny by creating an add-on to the language called JSX. Now, over the years, they moved on from a functional class-like way of JavaScript and started to develop an elegant way to survive and built a way to develop applications using component-based classes because JavaScript got classes. Now, the chief developer learned that the class-based way of her people, and she was very excited about that, but she always wondered if there was something more to the language that might be able to come in and play a role later on in our story.
Isn't this usually where she sings a song?
It is, yeah. I can do that.
Go ahead,
I'll get
please.
us demonetized again.
I think if you sing it, it's fine, right?
I guess. You don't want that.
Might get us banned.
Yeah. So she thought of the class-based approach to what they were doing was just too verbose, and she constantly pushed for a new way of doing things, but she was shut down because classes are the way of her people, of her development team.
And did she know the way?
She did because of that. That was all she'd ever known.
This is the way.
An older programmer on the island, think of her grandma Tala from Moana, showed her a hidden cave that contained JavaScript classes' true heritage. And she realized that they were once function-based and they could be again. So she told her lead developer of this revelation, but he simply carried on that state could not be managed in a function and that her ideas were as wacky as trying to go beyond the reef of their island. Well, that's exactly what she did. She set off to find the great JavaScript demigod Monad to restore the state of the function. Restore the state of the function and bring efficiency to her dev team. Now, upon discovering Monad, he told her of the ways in which functions could not work until they set off to find his missing hook. Only then could he restore the state and restore functional components.
Wait, you got to work your welcome in here somehow.
Yeah. I don't know how.
I see what's happening here. You're face to face with JavaScript, and it's strange. You don't even know how to feel. It's adorable. It's nice to see that programmers never change. Open your eyes, let's begin. Yes, it's really me. It's Monad. Breathe it in. I know it's a lot. The code, the state. When you're staring at a programming concept, what can I say except you're welcome? Let's see.
Thank you so much for that.
I lost my... all right. If I'd thought of this ahead of time, I could have written this out, but I was trying to do it in real time, and I just failed.
I disagree 100%. That was not a fail.
Yep, that was amazing.
Keep going, Nick.
So Monad told her that he needed to find his hook to be able to restore the state in functional components. That developer was curious, though. What is this hook you speak of, she asked. And this is where I kind of trail into Coco, because that's another favorite of my daughter's right now. So Monad says, imagine that your ancestors are in the afterlife. If you want their memory or their state to live on, you need to put their picture up on the ofrenda, or in this case, call them as a function within your component. And now when that happens, what happens to your state in that afterlife? Well, it lives in this magical world of memory. And it can live on in that memory for as long as you keep its picture their picture on your ofrenda. And as long as that's up there, it will be living and can be accessed by your state component.
Remember me.
As soon as you neglect to call it, its state gets cast to the afterlight called the garbage collector. Now, the order of which you put up those pictures really matters, or the order in which you call those functions really matters, because it helps the environment map the correct state to the correct hook call. And Monad also explained that hooks need to be called every time, and not just conditionally, like not just on Dia de los Muertos, but every day, every time. And they need to be called by the top level function in a functional component, and not just inside of some kind of callback. Now, Monad continued to explain the basics of use state, use memo, and use effect to this developer, and then went on to explain that his hook was unlike any other. It was a custom hook. Now, with this custom hook, Monad could use the underlying functionality of the other hooks to construct the perfect hook to destroy the extremely verbose monster to class and restore the heart of the function, or the state of the function, to the development team.
To class.
To class.
Are you done?
Almost.
Okay. Because you stopped like you're waiting for an applause. I feel like we're not quite there yet. Please continue.
So Monad's custom hook could be used to recall the existing application state, but it could also be used to have an effect on the world around it, because it could use effects. And he could also listen to the ocean, mouse clicks, page scrolls, and other things. And he could establish a plan for when his component was cleaned up or removed. And he could talk to the all-knowing cloud by using fetch. Now, as they faced to class in an epic battle, the developer realized that she could make a custom hook, for hooks were just a way to hook into her environment, React in this case, and then combine that with the strength of other hooks like Monad's hook. She could vanquish to class to the murky syntactical depths. Now, with this new power, she returned to her people once and for all replaced their class-based components with functional components supported by the power of hooks that were within them all along. The end.
Well, if I'm being honest, I haven't seen Coco, so you lost me there. But A for effort, and I just have to say, you worked harder on that than I work on being productive in TypeScript. So, congratulations.
I'm so productive with TypeScript, I have time for this.
You had time to write this story because your Vim and TypeScript tools just wrote themselves today, I suppose. Well, I surely can't follow that, so we'll have to break right here. So I have some time between me and that to come up with my ELA 5. So let's break. We'll be back with Bitcoin.
What's up, party people? This episode is brought to you by our friends at Square. For our listeners out there building applications with Square, if you haven't yet, you need to check out their API Explorer. It's an interactive interface you can use to build, view, and send HTTP requests they call Square APIs. API Explorer lets you test your requests using actual sandbox or production resources inside your account, such as customers, orders, and catalog objects. You can use the API Explorer to quickly populate sandbox or production resources in your account. Then you can interact with those new resources inside the seller dashboard. For example, if you use API Explorer to create a customer in your production or sandbox environment, the customer is displayed in the production or sandbox seller dashboard. This tool is so powerful and will likely become your best friend when interacting with, testing, or playing with your applications inside Square. Check the show notes for links to the docs, the API Explorer, and the developer account sign-up page, or head to developer.squareup.com/explore/square to jump right in. Again, check for links in the show notes, or head to developer.squareup.com/explore/square to play right now.
So since Bitcoin is back in its bull run, spent a few years in a bear market and then came roaring back from, I think, something like $4,000 a year ago to $60K per coin and around there today. People are interested once again in this crazy world of cryptocurrencies. And so we thought it'd be fun to explain Bitcoin like you're 5, because it is a difficult thing to explain, difficult to talk about, a lot of ins, a lot of outs, a lot of what have yous. The first way I would like to explain this is by stealing a tweet from Theophyte on Twitter, which I thought was a hilarious way to explain Bitcoin. Somebody tweeted out, "I still don't get Bitcoin." And Theophyte replied, "Imagine if keeping your car idling for 24/7 produced solved Sudokus you could trade in for heroin." That's pretty classic, right? Yeah. So, of course, there's your bear explanation. And there are lots of downsides with Bitcoin, specifically around energy use and whatnot. But there is also some real value to the network. And I'm not going to explain how Bitcoin works like we're 5, but I thought maybe I would try to explain why some people think it's valuable like you're 5. So here we go. Imagine that you're playing Monopoly with some friends. And one person decides, maybe they're the homeowner, usually house rules. They decide they're going to be both the banker and the rule enforcer. Pretty typical. Everything starts off okay, but then the banker starts doing some things that you don't appreciate as someone who plays the game. For example, they start injecting new money into the game, but not equally to everyone, just to themselves and some of their friends. They change the rules about how much money you get for passing go, what you can go to jail for, and for how long. They create over-the-top transfer fees and laws about who can trade with whom, etc. Eventually, you and a few other people in the game decide that you want to transact without the banker's rules, permissions, fees, and so on. But you can't use the Monopoly bucks because the banker runs that whole system of things. So instead, you start a group text on your phones. And each time you want to transfer money to and from each other, you put that in a text. Maybe you text, "I'll send 5 Shroot bucks to K-Ball." And then you text that out. Everyone involved in this new way of sending money is in the group text. So that's how you keep each other honest. Bitcoin is the group text. The end. What do you think?
I like it. I'm going to package that recording up as a non-fungible token and sell it later.
Now you're talking. K-Ball, thoughts?
Yeah, I feel like it's okay. I might add that every time you send a text, it actually has to send everybody, or like something about the ledger getting longer and longer. So you send a text, it actually has to send the whole history of texts every time so that you don't accidentally lose track of where the money's been.
That's true. So like when you join a group text, sometimes if you add someone to a private Slack channel, for example, it may say like, "Hey, do you want them to just start right now? Or do you want to give them the entire history of this conversation?" And with Bitcoin, that's non-optional. Like everybody has to have the entire history. Now there are like thin clients and stuff where they don't have to have that, and other people, you can trust other people to keep the entire history. But yeah, well said. You're sending lots of texts around the world, aren't you?
Yeah. You could also add an element about like the text getting so long, they fill up your phone. So you have to buy fancier phones. And
yeah, the whole mining and mathematical computation thing is not in the analogy. That's why the analogy falls apart. But that's why I said it's more about why people would want to do this and less about how it works, right? Conceptually, this side conversation that is outside of this other system, which doesn't have the rules that you may not appreciate, is why people see the value there.
Yeah.
But how it works is, yeah. Oh boy. Chat room loved it too. So yay for me. Maybe it's because mine wasn't like a 30-minute epic of multiple movies entwined together in order to tell a story of evil and good, although.
Got to keep those kids entertained.
It could be.
I also like how you focused on the financial piece of it and not the whole blockchain thing, because I feel like a lot of people go all out on blockchain being a solution for stuff rather than being like a really slow distributed database.
Right.
But the financial aspect is where cryptocurrencies actually do have some pretty interesting characteristics, and the ability to create these like microcurrencies, or I guess Bitcoin is pretty macro at this point. Like that has some really interesting potential effects.
Yeah, exactly. And I think long term, like where does it go long term? I think Bitcoin is the idea and like an instantiation of the idea that made it possible. but I think that these multi-use, build on top of platforms, streaming money systems ultimately become probably the end game, or maybe not the end game, but like the major game down the road. And a lot of those are solving a lot of the problems that Bitcoin has, such as the energy use, etc. All right. Well, that's Explain It Like I'm 5. Thanks for playing. And next up, we are going to change our focus to project focus, which is where we take a particular piece of software, a project out there, usually in the open source world, and we give a summary of it. We check it out. Maybe we dig in a little deeper. Today, we'd like to actually dig in a little bit to some source code. And the topic of today's project focus is called Vite. Now, K-Ball, you mentioned Vite a few episodes back.
I did.
As something that's been on your radar. You've been interested in this. We haven't done a show on Vite. We did a show on WMR, which is a similar tool to Vite, but we thought we would spend some time, the three of us, just taking a look, reading about it, picking it apart, maybe finding some interesting bits about how it does, what it does. You want to kick us off, K-Ball, with what Vite is for everybody, and we'll go from there.
Yeah. So Vite is a very fast, modern front-end dev build tool. So it kind of takes advantage of a lot of the progress that's been made in terms of native ES modules and various other things to reimagine like a Webpack style thing to do front-end tooling that is super, super fast, has universal plugin interface, and is fully typed using TypeScript, which I don't know if anyone has ever dug into the Webpack build model and their tapping and plugins and whatever. It's really, really hard to understand. So I'm excited to see something like this that has typing built into it and has this sort of deep thinking built into it from the start. It caught my interest because I sort of follow the Vue community, and it was initially developed by Evan You for Vue, but then he pulled out the Vue specific parts and created this very tight core and plugin interface so that it could be used with any front-end framework. And I thought that was a really interesting model, especially for somebody who is so deeply into the Vue community, to do that. And kind of, when I saw folks who were involved with the React core team tweeting excitedly about Vite, I said, okay, there's something here. It's not just Vue. This is actually pushing the whole industry forward in some way.
That's honestly what kept it off my radar for so long. Is I saw it, but I'm not really tied into the Vue community, and I kind of thought of it as a Vue specific project, much in the way when we talked about WMR, I thought that was more of a Preact specific project.
Right. Yeah, it's kind of interesting because you borrow from the strength of the brand, right? Which is powerful, right? Like this borrows from Vue's brand, same people, same expectations, etc. And WMR borrows from Preact people's brand. But then also you kind of, by doing that, you also kind of pigeonhole yourself, at least in people's perspectives or perceptions, which can ultimately limit your exposure. So it's kind of a catch-22, but I definitely thought this was just a Vue thing for a very long time, until today, honestly.
Yeah, I saw you put the tweet out talking about Vite, the Vue project, and I was like, "Oh, Jared,
yep.
we're gonna have to."
I hadn't done my homework
right.
yet. Put me right, K-Ball. Put me right. So one thing that's cool about the way this works, and we can go through some of the comparisons because it is similar to a lot of other tools out there right now, Snowpack and WMR specifically.
Yeah,
is one of the things they do that make it, I guess, conceptually different or interesting is they kind of bifurcate the idea of not just development and production, but the idea of dependencies and source code. Did you guys see that? So one of the things they do is they solve the problem like slow server starts. This is like in dev, right? And slow updates and these problems like as you get more and more code into your project, right? Like you got to wait seconds for your server to start up. You have to wait multiple seconds for your files to reload after hitting save, etc. Or in the browser even to refresh between saves. And so they're trying to solve that problem in dev and make that way faster and way better. And so the way they do that is that they split it up just conceptually. They say, okay, everybody has dependencies and everybody has source code. And what a lot of production bundlers do is like their whole point is like, well, we're going to merge and shake and then minify and then like do all this transpilation and crap. And then we're going to like spit it out, and it's one big thing. The way they think about it, though, is they actually think about it in terms of your dependencies as one type of code, and then your source code as another type of code. And so they take your dependencies and they use like pre-bundling, and they use ESBuild super fast, and they treat it like it's a dependency. How is a dependency different than source code? Well, it's not going to change very often, right? Like you pull it in and you leave it, and you're going to import it or whatever, but you're not going to be changing it unless you upgrade a version or something like that. Whereas your source code, you're changing it constantly, right? There's certain aspects of the site you're working on. These are very high churn. There are other aspects that you don't even need at all because you're not working on those, so they can be shaken out or whatever. And that allows them to make it way faster, the dev server specifically, while you're working on it with Vite. I keep wanting to say Vite, even though I know it's Vite.
Yeah.
Forgive me if I squeeze a Vite in there.
Looking at it a little bit, they go so strong as to say, hey, we're actually going to cache these things forever, essentially. And they key the cache with the version of the dependency. So if you upgrade your dependencies, it's going to update that version so that invalidates the cache and it works forward.
Mm-hmm.
But they are operating under the assumption here that default case, your dependencies never change unless their versions have changed, which makes a ton of sense for somebody working in a web app environment.
Yeah, and so for those, they can use ESBuild, which is the tool written in Go that's like 1,000 times faster than other bundlers. I don't know the exact numbers, but 10 to 100x according to Vite's website. So I overstated by an order of magnitude. Take it back. 10 to 100x, still pretty fast. And then the source code, they just use native ESM for that in dev. And so a completely different way of handling it. So that was cool. What else about Vite do y'all find interesting?
Well, let me ask, do you see Vite and like WMR, and would you put it on the same level as things like ESBuild, or is that at a different level in the stack? Or I guess another way to put it, do you see this as like the modern descendants to things like Webpack and Parcel, like things, more modern tooling written for modern ES module JavaScript?
I think it's introducing a layer. So Webpack, you have Webpack and you have Webpack Dev Server, and they kind of ship together. And I think they're reasonably entangled, or at least like Webpack Dev Server just works with Webpack. This is built on top of ESBuild and Rollup, and it is just that dev server layer of utilizing the underlying bundling tools in a smarter, potentially, or at least taking more advantage of modern practices way, but it's handling the web server piece of it. How do we use these tools to package things together and do a dev web environment that works really well and that also then translates to production?
Right. So it's explicitly not a bundler. So in dev, it will take your dependencies and you use ESBuild to bundle those. And then it will leave your source code as native ESM and just serve it natively in the browser. And then in production, it uses Rollup to still produce a bundle, a single bundle. And so some of that breaks down, like what's the difference between Snowpack and Vite. And they're very similar. Some of the implementation is different, but basically how they go about building for production is different. But neither one of them are bundlers. So think about it as like it uses bundlers, but it's not a bundler. Now, WMR, they do compare. There's a nice comparison page on Vite's website, which we'll link up as well, where they'll compare themselves to Snowpack, WMR, and Web Dev Server. And the question around WMR is, well, what's so different about those two? And the answer is not all that much. I think Vite is trying to position itself as more general purpose than WMR, which is like Preact plus general purpose, but has some Preact-y things built right in. If you remember that show, Nick, we did where, it'll generate a bunch of Preact stuff by default, etc., like in the scaffolding. Whereas WMR, I think, is trying to head the way of more general purpose. It sounds like Vite thinks that they're more general purpose than WMR is, but that's according to their comparison page. Hard to say exactly. The scopes are very similar. I'm not sure exactly if they work the same way. If you remember that Jason was talking about his roll-up plugin interface that they kind of standardized in order how WMR interacts with roll-up was kind of, they built this standard interface, and then Vite adopted that as well. So they're kind of like playing off each other, learning from each other, doing things slightly different. And WMR is, I guess, fine-tuned for Preact, whereas Vite is not.
I just saw when looking at that site, as they reference some of their inspirations for Vite, that the server is using Koa, which is kind of a fun alternative to Express that is very async focused and has some interesting programming models associated with it.
I wonder what gave them that decision. It'd be interesting to know what goes into that decision. So in addition to grokking the website and the README, we also thought it'd be fun to kind of dig in a little bit further, hop into some of Vite's code, at least conceptually. I'm not going to be over here reading aloud dramatic readings of source code. Might be a good segment, but it's not this segment. But poke around a little bit.
Set to Moana.
Yes, exactly. We'll get all sorts of copyright problems if we can continue hitting up Disney properties like this. Just poke around, see if we can find anything interesting in the bits. Now, I guess a meta question for you two that I'll also throw in on a little bit is, when you come to a project and you're beyond, I'm just going to use this. You're kind of thinking, I want to learn from this. I want to read about it. I want to read it. I want to consume this and play with it maybe. And you land on a GitHub page. What do you do from there? How do you approach a new piece of source code in terms of grokking it or trying to figure out how it all fits together?
The first thing I try and do is find the entry point into it. Like when I, if it's a library or something, when I call this, what's the thing that I'm hitting first? And then how does it get routed to something else from there? It's typically what I'll look into. For something like this, it's a little more difficult because it's like trying to find how, I don't know, I guess that's a way of establishing my footing in some way.
Right. What about you, K-Ball?
I have some of the same. I'll often look for an entry point. Sometimes what I'll do is depending on is this code solving a problem that I'm already somewhat familiar with or that has touches on that? Sometimes I'll look for, okay, this is touching this problem domain. Let me find where it's dealing with that. So I was looking at Vite a little bit and I saw that it was doing SSR and I thought, oh, SSR is kind of pretty framework specific. I wonder what are they doing within Vite to deal with server-side rendering, given that that's something that, for example, React does very different than Vue. And so I just started digging around in that folder a little bit. So that's the other approach is instead of looking for the entry point, how am I going to call it this? It's, okay, I know it's dealing with this problem, and that problem is interesting to me for one reason or another. Let me go and find out how it's dealing with that.
And going to this, I will say that one plugin that really helps navigate code on GitHub is one like Octotree that gives you a file drawer right on GitHub. So you can easily look at the file tree without clicking and then clicking in and clicking in. So it's much easier. But immediately going to this, I see that it has a packages directory. So it immediately makes me think, oh, this is a monorepo. And so exploring it from that sense of, that's how I can figure out how to navigate it, is treating it as a monorepo. It's not using Lerna. So that's the only monorepo configuration I'm familiar with.
Yeah, so places that I'll usually start at the README. That's the clear and obvious one. Read the README. Oftentimes in the README, there will be instructions on how to contribute. And usually that's where they'll give you entry points or they'll give you places to start or at least how to get it onto your machine, etc. This one has a nice contribution guide. So if you start in the README, you find the contribution guide. That's normally going to tell you a whole bunch about getting started. In fact, theirs is pretty well written, better than most open source projects I come across. And they'll tell you how to get the repo set up. They tell you they're using Yarn. They do tell you that this is a mono repo. So you drilled that, Nick. And they'll tell you where the packages live, where the test directories are, and then, of course, PR guidelines and all that kind of stuff. Now, it's different whether you're trying to actually just understand it or if you're actually trying to hack on it. Maybe you don't care about the PR guidelines. I don't at this phase. I'm just trying to understand where things live. So start there. And then also package JSON. A lot of times you can figure out things about a project by its dependencies and also its npm scripts and stuff, right? Like if you go look at the scripts key in the package JSON, you'll find a lot of the entry points. And this one is no different. At least you'll find out how to run the tests, what they're using, the subcommands they're using in order to run the tests. Tests are also a great place to start. So this is a monorepo. So if you go inside packages, you can find out, well, it has a plugin architecture. So there's a Vite directory, and then there's plugin Vue, plugin Vue.jsx, plugin React Refresh, plugin Legacy. And so now I know, okay, there's some sort of plugin architecture that's being used, and these are like, the official first-party plugins. And this Vite directory is probably where the bulk of the logic is. Then they also have the playground, which is that. Maybe that's part of whatever monorepo system they're doing, or is playground a pretty typical directory path for monorepos or for projects? It's not something that I'm used to. Is that directory playground pretty common?
Not that I've seen.
Yeah, me either.
Yeah, I don't know.
Then you drill down in there, you see they have a bunch of .ts files. So then you close the browser tab and you move on.
What's that extension? What was that?
Then you realize this project is trash because the .ts is .trash. That's what it stands for. And you move on. No. So that's kind of how I get started, right? It's like README, tests, package JSON, contributor guidelines. And if you can't get a good idea of at least where to start from there, it's probably not a repository worth, spending time reading. Because reading is a great way to learn how to write software. Just like good writers read a lot, I think good software writers read a lot of code, and especially code from people that you think is high quality engineers, as the Vue and the Vite team are. Don't want to give Vue too much credit because it's the Vite.js repo. Anyways, as we dig in, you mentioned the SSR stuff, K-ball. Anything else pique your interest in the code itself?
Yeah, I was looking around. I thought there's some interesting, probably easier to understand than the SSR stuff, looking at how they do hot module reloading, or just kind of how their client is set up, because they inject a client in with your app code, at least in development, to be able to do hot module reload. So that might be a fun place to start.
Cool. Anything else on Vite?
Now that I know that it's not Vue specific, I see myself playing with it in the future. Not that I have anything against Vue, I just haven't gotten into Vue.
That's a sick burn.
I want to get into it, I just haven't found a reason yet.
What's up, party people? This episode is brought to you by our friends at Square. For our listeners out there building applications with Square, if you haven't yet, you need to check out their API Explorer. It's an interactive interface you can use to build, view, and send HTTP requests they call Square APIs. API Explorer lets you test your requests using actual sandbox or production resources inside your account, such as customers, orders, and catalog objects. You can use the API Explorer to quickly populate sandbox or production resources in your account. Then you can interact with those new resources inside the seller dashboard. For example, if you use API Explorer to create a customer in your production or sandbox environment, the customer is displayed in the production or sandbox seller dashboard. This tool is so powerful and will likely become your best friend when interacting with, testing, or playing with your applications inside Square. Check the show notes for links to the docs, the API Explorer, and the developer account sign-up page, or head to developer.squareup.com/explore/square to jump right in. Again, check for links in the show notes, or head to developer.squareup.com/explore/square to play right now.
We do have a bit of a playground. Nick and I, but mostly Nick, is our quiz show repo. So if you ever listened to JS Danger or watched it on YouTube, you know that there's a pretty cool JS Danger game board that I imagined and Nick coded up, and Cody Peterson designed much of it. And it was originally written in Dojo, right, Nick?
Yep.
And it's still written in Dojo today. So if you want to see a Dojo application written by Nick that he's very proud of, I don't know, I'm not sure about that last part, but it's out there. It works. Yeah, it's awesome. It's TypeScript.
Ooh.
You can check that one out.
Is there going to be a Dojo plugin for Vite?
Instead, I think he's going to switch it to React. Isn't that right, Nick? You're
I
rewriting.
have been playing with rewriting it in React. Yes.
So,
But
real
still
quick,
TypeScript because Jared loves that.
Yeah. So, long story short, is I started writing some TypeScript and got very angry and lashed out in our JS Party channel of the Changelog Slack. So, if you want more of me making fun of TypeScript or complaining about it, then join that channel. And Nick coming to its defense, like Monad's hook, the hero of the story. Anyways, tell us about this rewrite. You're going to use some React. You've been trying some Tailwind. What's going on there?
Yeah. I've been playing with React, moving it to React instead of using Dojo's middleware, using React hooks and specifically React context to hold the application state of the game. And another new feature right now, if you want to create a new game, what Jared has to do is create a game.json file, put it into the repo into a certain place, and then change a string somewhere, and it will read that game.json and populate the game that way. But one thing I'm looking at is just having that pull from GitHub gist, so you can just give it a query param of a gist ID, and it will go get that game from there and then populate it. And I got a concept of that working in my completely broken React branch. But it's pretty cool, and I think it'll be fun to play around with. And it's moving from Dojo's kind of build system that is based off of Webpack to right now I'm playing with Snowpack. But I would also like to take a look at Vite and or WMR for this to kind of see a comparison. It's a fun playground to experiment with that because it's a relatively small project, but still complex enough that it's fun to work with and has a lot of good use cases.
Yeah, it has something. I mean, it has state, obviously. The scores are tracked, the point values, it's reading in some data. Of course, it's just JSON blob, but you could change the way that worked. It could actually, so that you could write it in a web interface, which would be cool. But it has, some keyboard shortcuts. It has some music, some audio sound integrations, a fairly interesting UI with some overlays, and it looks like the Jeopardy board game.
Mm-hmm. And most importantly, it has never crashed during the game.
It works every time.
Ooh, I have a question looking at this. Oh, TypeScript master. I notice as I look at this code for the first time on this quiz show, there's a file called app.m.css.d.ts, which first of all, that is far too many extensions for any file.
Oh,
ever.
Cool. Let's team up on him, K-Ball.
Oh, no. Yeah, it's actually fascinating.
Yeah. Can you expand on that?
Sure.
What's going on there? Because it looks like app.m.css. I'm not sure what that M is doing there already, but looks like just pretty vanilla CSS. Why do we need it to be typed?
Yeah. So it is just vanilla CSS. The .m signifies it as module or modular CSS. So it'll be scoped to that component, in that case, app, or there's a contestant.m.css, I think. And that has classes that will only be scoped to that, meaning that at build time, the class names will be rewritten to something random that is specific to that. So you kind of lose the cascade part of CSS, and it'll only be scoped to that file, and you won't bleed out styles anywhere else. The .m.css.d.ts file is very simple to talk about, but it's just that's actually generated by the build system. So it's not something that I wrote directly. The build tool is going in and looking at that CSS, and it sees all of the class names, and then it creates basically an interface for all of those class names. So it's saying that when I import this module, this app.m.css, when I import that in my TypeScript, it's going to give me this interface that looks like this so that I can have IntelliSense on my class names, and then those will just be replaced with the random strings that get generated at build time. But it's just a way to have typed modular CSS, and then those files are just checked in.
Mm-hmm. What do you think about that, K-Ball?
All right.
I like it better than CSS and JS, to be honest.
That's why I tell him.
Here's the one thing that I dislike is checking in generated files.
Yeah, totally.
Do you have to check it in?
No. You could probably ignore them because they're not important at runtime, right? I don't see why you would need to.
I don't know.
I could be wrong, but I don't think so.
I also don't like checking in generated code, but That's just me. I know there's people that actually take their passwords, encrypt them, and check those into their repositories. And that's like common.
Why even encrypt them?
Why?
Yeah.
I mean, you could skip that step, I suppose. I'm sure people have. Sort of GitOps thing where like everything lives inside of Git. And as long as your encryption algorithm is not able to be brute forced, then it's just as safe as anything else, I suppose. But over time, all algorithms have fallen eventually. So you'll want to just rotate those keys on a regular basis.
Now, K-Ball, I will tell you that I have in the React rewrite of this, I've been trying to use Tailwind instead and trying to write as little custom CSS as possible, just rely on that. So I have replaced these .m.css.d.ts with extremely long Tailwind strings right inside of my React component that are just the class name, all of the classes listed out.
Yeah. I have not had the chance to really do much with Tailwind. I've been using styled components recently. There is value to CSS and JS, particularly, but I'm not sure you get that much incremental value once you get beyond module scoping, honestly. Like, I think the module CSS and I think LinkedIn published a project on this and things like that. Like, being able to scope by component, super, super valuable. Most of the rest of the stuff that is in CSS and JS, pretty annoying, to be honest. And
For sure.
like, there's a lot of, I mean, I don't know. I'm dealing with it. It's fine. But our tendency to push everything into JavaScript or TypeScript or whatever is, there are situations in which it's extremely valuable. And for a very large number of projects, including this, how many line project we have here for this 58 commit CSS or quiz show project, I suspect going all the way to CSS and JS is going to be overblown. So your Tailwind classes straight in there, that might actually be a better approach.
Yeah, except I just it doesn't look great because it's just one long string and then it just, it doesn't get moved to multiple lines or anything. I guess I could do that.
That's kind of a Tailwind problem though, isn't it?
Yeah, totally. One thing that I have been playing around with is, at work I use Material UI, and that's a React library that's based on Material. And it has a whole bunch of components, and one in particular that I really like is called Box. And it's just like the most generic component that has all of these properties that you can set on it. So you can set MY for your padding Y, or MT for your padding top, or margin top. Sorry, margin in both of those examples. But you can just set all of these, and then it will pull those out and generate custom CSS and inject that into the page for that. So it's I go out of my way to just write what I want on these props that are nice and neatly organized in the component itself. And then CSS is generated for them later.
Some real-time follow-up. I just ran clock on our repo. That's the command line tool CLOC, which counts lines of code. And there's about 682 lines of TypeScript and 300 lines of CSS and 11 lines of HTML. That doesn't make sense. Maybe it does. So under 1,000 lines of code project.
How many of those lines of TypeScript are types for your CSS?
Good question. I do not have the clock skills to run the diffing and the right flags to figure that out, K-Ball, but after the show, Nick will count them by hand, I'm sure.
Oh, yes.
I mean, I'm just kind of poking holes here. Use the tools that work for you, right? All of these are just tools. Some of them work well in some situations. Some of them work well in other situations. Small projects have different needs than large projects. Projects with many contributors have different needs than project with one or two contributors. Do what works for you.
Yeah. I would love to see some more iterations of this project in different styles, different toolkits. Nick's going to rewrite it in React, so we'll at least be able to compare a dojo, which is an older dojo at this point, because a couple of years ago you wrote this initially, maybe 18 months ago.
About a year, yeah.
Okay, just a year. So maybe not that old dojo. Just with other things. I'm here's what it looks like that, and here's what it looks like this, and you can compare and contrast. I know there's cool projects out there like the To-Do, what's that one called? To-Do MVC is one, and there's one that's called a Real World App or something, where it's more of a real world app that people write, and they'll have an Ember implementation, a React implementation, an Angular, blah, 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 blah. And those things I found are pretty valuable.
Maybe we should turn this into a monorepo with several implementations.
There you go. Bust out your VS Code and get going on that, Nick.
What's that?
Hashtag Vim is dead. All right. That is our show for this week. Thanks for hanging out with us, letting us explain things in a ridiculous fashion as if you're all 5-year-olds in ways that even 5-year-olds could not understand. For poking around.
I don't know if I understood Nick's, and I'm a lot more than 5. But I loved it. Don't get me wrong.
What can I say except you're welcome?
Oh, gosh.
Ching.
With that, we just end the show because there's nothing else to be said. You already said it. You're welcome. That's JS Party for this week. We'll talk to you next time. Thank you for listening to JS Party. Please do tell a friend about the show. It's the #1 way people find new podcasts they love. We have awesome sponsors supporting the show. Thanks again to Fastly, LaunchDarkly, and Linode. On the next JS Party, K-Ball and Nick are back, and they are chatting with Amel all about work environments, happiness, productivity, life stuff. That is an excellent conversation, so stay tuned for that one. It'll be ready to put in your ear holes next week.
Can you explain it like I'm 5? Please explain that like I'm 5-year-old. Like I'm 5, please. I spell the 5. I spell for you. 5. I 5, please. Can you spell like I'm 5? Hey, spell like I'm 5. Can you spell like I'm 5? Explain me a 5. I 5, please. Explain me a 5. You spell like I'm 5-year-old. You spell that I'm 5 years old. You spell that is this 5-year-old. You spell that is 5-year-old. Can't that I'm 5 is Spanish.